Okay, practice problems. Bob, there's his mass, and Jane, there's her mass, are sitting 1.85 meters apart. What is the gravitational force of attraction between them? So I'm going to let you guys go ahead and pause this in a second, and I'll pop the answer up at you. Okay, so go ahead and pause it now. Okay, there you go. So, a couple things here. I didn't put my units here just because it gets really tiresome putting those units down because they're quite long. And yeah, I'm okay if you guys don't too. If you want to skip those, just make sure that you have your units in your final answer. Okay, number two. What is the force of attraction between Mercury and the Sun? So we've got the data table below here. So we're going to need some of this stuff. So, um, what was it asking for again? We needed force of attraction. So we know the mass and we know the radius of both of those things. But just make sure when you're looking through this, it says radius of the object. That would be like the radius of the Earth. That's not really what we want, right? If we're talking about if this is the sun and this is the Earth over here, and we wanted to figure out what the force of attraction was between them, I don't care what the radius of the sun is, right? I care about what the distance between them is. And that being said, too, the mean radius, when it says mean radius of orbit, that is from center to center. And actually, it wouldn't really matter anyway because the distances that we're talking about are so huge between here and here that the radius in between them is totally negligible. Doesn't really matter. So this is the one we need when we're talking about r. We're talking about the radius of orbit. All right, so go ahead and see if you can do that one on your own too. So pause the video now. Okay, there you go. If you didn't get this answer, but you had, let's say, the same numbers, probably an error in your calculator, or you maybe you forgot the to square it on the end there. One way to make sure that you're right too is in your calculator. I would do the top, push enter, figure out what that is, and then go divided by this. That will just make sure that you are actually doing your order of operations right. Okay, next one. So this was the type of question that I skipped over before. It's going to be a common one. It's going to come up more in this course, and it's going to come up in Physics 30 as well too. So it's not that bad if you kind of get a grasp on it. So it says the force between two objects is measured to be 45 newtons. What is the force if one of the masses is tripled and the other doubled, and the distance between them is halved? Okay, so we're going to start off with our formula. We're going to say Fg is equal to big G m1 m2 over r squared. So as of right now, this is all equal to 45, right? So everything that I have written here, that's all equal to 45 newtons. Okay, with me? Now what we're going to do is we're going to introduce some numbers. So I'm just going to write this a little bit different here. I'm going to say now the case is going to be that we're going to have still G, and it says one of the masses is tripled, so I'm going to write 3 times m1. The other is doubled, so I'm going to write 2 times m2 over. Now this has to be in brackets because the second or the last thing says the distance between them is halved. So I'm going to say 1 over 2 times r, and that's all squared. Or another way that you might like to write that instead might be like r over 2. Same thing, right? Okay. Now, the last thing I'm going to do, I'm going to rewrite this one more time just so we're kind of clear here. G, we've got 3 m1, 2 m2. But I'm going to write the bottom as what it would be if I put this 2 into both of these, right? So this would be r squared over 4. Okay. Now what I'm going to do is I'm going to take all these numbers out of here. I'm going to pull them all out to the left. I'm not really doing anything other than just like writing them off to the left. So I'm going to rewrite this as Fg is equal to, I've got 3 times the 2, and then I've got G times M1 times M2 still left on the top. And over here I've got that 4. But you know what we're going to do first? I'm just trying to think of the best way to do this to have it make the most sense. This we've got r squared over 4 on the bottom. If you ever have, something over something and then over something again, so kind of like the situation here, that's the same thing as having the 4 up on the top. You can just move it up to the top. Hopefully that made sense. But yeah, you can do that, right? So what I'm going to do is we also have that 4 written up top as well. So that's going to be times 4 and then over r squared. Now the last thing I'm going to do is go FG is equal to 3 times 2 is 6 times 4 is 24. So I just multiplied those all together. And then I've got left is G M1 M2 over r squared. And remember now, I've already said that this is equal to 45 newtons. So all I need to do if I want to figure out what FG is now is I just need to go 24 times 45. So we get FG is going to be equal to 1,080 newtons. So I hope that made sense to you guys. This is probably this part here was probably the hardest of this question, and just recognizing that if maybe you were confused by this, I'm just gonna make sure that you know what I'm doing here. So let's say I had 4 over 3 and then over 2, something like that, right? Well, what I did over here was that if you've got 4 divided by 3 over 2, dividing by something is the same as multiplying by the inverse of it. So this is actually the same thing as saying 4 and then flipping these two things upside down. So that's going to be the same thing as saying 4 times 2 divided by 3. Right? Hopefully that made sense. So try it out in your calculator. If you go 4 divided by 3 over 2, and then 4 times 2 divided by 3, it's the same thing. You get the same answer, right? If you put the brackets here when you do that calculation. Okay, so I'm going to end that there. Make sure that you guys know that your hand-in assignment is going to be due, and this is the data table that goes with it. One thing that I've found in the past, though, is that the answers here might be off by like 1 sig dig or something. So if it is, don't worry too much about it. That's a problem with the sheet and probably not a problem with you. Just make sure you keep all your sig digs till the end, though. But if it doesn't match up exactly, don't freak out about it. Okay, and number 8 is a tough one, so give that one a try if you feel up to it. All right, that's it for that one.